first time, scientists have produced a large-scale, three-dimensional picture of dark matter. That's the invisible mass that's believed to make up most of our universe. But until recently, it's been hard to prove. And joining us now to shed some light on this is Max Tuzel. He's a physicist with the Ontario Science Centre. Thanks for coming in. And I guess for us non-scientific types, like what exactly is dark matter?
Well, it's matter, like mass, like you and me have, but it's not the mass that we tend to think of when we think of stuff. It's a mass that has, okay, so the dark part has nothing to do with sort of evil or diabolical things. It basically just means that we can't see it. So when we look in the sky, when we look across the universe, it doesn't appear. And that means that it doesn't interact with light. And so you might say, well, where did we come up with this? Well, we observed galaxies, and basically we observed that they rotated in such a way that they should have a mass that was much more than what we observed.
Well, we're looking at some pictures here of dark matter on the right, and then the normal matter on the left side. Like, what is the significance that now that we can see this?
Well, basically, we've known about that it should have existed, that it does exist for a while, but we really didn't have a good sense of how it was structured. So this is sort of knowing the role of one of the big actors in the way that our universe has been structured. So now we get a chance to see what it actually looks like.
In three dimensions, as we're looking here.
Exactly.
I mean, this is a phenomenal picture.
Yeah, so those bright spots that you see are normal matter that were found at the center of these sort of clumps of this dark matter that are connected with sort of strands or filaments that connect them. And on the whole, it's pretty much what we expected to see.
But without the Hubble, I mean, that was really the telescope up there,
absolutely.
the big Hubble.
Has done some amazing
thing, and it's Hubble that really got this to show you scientists what this stuff was out there in the universe.
Observational part of science is great, and the Hubble has really done an amazing feat.
So what does this really mean, though, for scientific research, now that this has been seen and photographed?
Well, this is sort of another chalk on the board for the dark matter theory, which is a big part of how we view the universe. We found out that it's a huge part. Actually, the matter that we do see is only about 5% of all the stuff in the universe. This stuff takes up about 25 to 30%. So it's a much bigger, like I said, actor in the play as of the universe unfolding. So when we want to study the universe as a whole, this dark matter is actually much more important to study than regular matter.
How exciting has this been for physicists, scientists, amateur astronomers to see this?
Yeah, I think it's been amazing just to be able to get images for the first time of really what it looks like and the shapes. And like I said, it's mostly consistent with what we're doing, with what we've seen. But there are some details that are a little questionable, and we're not yet sure if those are just errors in the experiment or whether they actually point to some sort of new physics going on.
Okay, another step in the great unknown. Thanks for joining us and telling us about it.
Thanks.